Well, for the first question on the worksheet, section 3.4, it says the area of a circle is pi over 4 d squared. So area equals pi over 4 d squared. And how fast does the area change with respect to the diameter when the diameter is 10 meters? So we want to find a prime of d, and when we do that, we'll bring the exponent down and we get 2 times pi over 4 d, and that reduces 2 goes into 4 twice, pi over 2d. So a prime of 10, replacing d with 10, we get pi over 2 times 10, which equals 5 pi, and the units are meters squared. And we're done with. Okay, we're doing section 3.4 in calculus. So the question number 2 in the worksheet, or in the notes, says, given the metric free fall equation of S of t equals 4.9 t squared, there it is, how many meters does the ball fall in the first 2 seconds? Well, we just have to evaluate S of 2, which equals 4.9 times 2 squared, which equals 4.9 times 4, which equals 19.6 meters. And for B, it says, what's the velocity, speed, and acceleration when t is 2? Well, the velocity is just the derivative of the distance, so s prime of t equals the velocity. And so now we'll take the derivative of that, and we get v of t equals negative 4.9 times, and taking the derivative of t squared, we get 2t, and that equals negative 9.8 meters per second. Now, the reason that's negative is because it's falling. So when you have velocity, velocity is a vector, and vectors have direction and magnitude. So the direction's indicated by the sign. It's going down, and the magnitude is 9.8 meters per second. On the other hand, the speed is just magnitude, so the speed is 9.8 meters per second. Now let's go a little farther with this. It says, what's the acceleration? Well, the acceleration is just the second derivative of distance, or first derivative of the velocity, so v prime of t equals acceleration of t, which is going to be gravity. And so a of t, and when you take the derivative of 9.8, take the derivative of the velocity, you're simply going to get 9.8 meters per second squared. But acceleration is a vector, and that's accelerating downward, so that'll be negative 9.8 meters per second squared, and we're done with that. For our Final question. It says, relative to the production of 8 to 30 radiators per day, the cost, C of x, equals x cubed minus 6x squared plus 15. And the revenues, R of x equals x cubed minus 3x squared plus 12x. Your shop currently produces 10 radiators a day. About how much extra will it cost to produce one more radiator a day? And what is your estimated increase in revenue for selling 11 radiators a day? Well, about how much extra will it cost to produce one more radiator? It's just a matter of taking the derivative of C of x, and I've got C of x right there, so C prime of x equals 3x squared, reducing the exponent by 1, putting that exponent value out in front, making it a coefficient on x squared, minus 12x plus 15. We're using the power rule. So now C prime of x, the derivative evaluated at 10, will give us a very good approximation of the cost of producing one more radiator. So replacing every x with 10, we get 3 times, and 10 squared is 100, minus 12 times 10 plus 15. So that's going to be 300 minus 120 plus 15. And when we sum those, we get 195, and that's going to be dollars. So it's going to cost approximately $195 to produce that 11th radiator. Well, to continue on with this problem, Part B says, what's the estimated increase in revenue for the production of this 11th radiator? So there's our revenue function. Our first task is to take the derivative of that, and using the power rule we get 3x squared minus 6x plus 12, and now we're going to evaluate that for 10, and 3 times 10 squared is 100, and 3 times 100 is 300, minus 6 times 10 is 60, plus 12, which equals, and negative 60 plus 12 is a negative 48, and subtracting 48 from 300, we get 252, and those are dollars, so your increase in revenue for making that 11th radiator will be approximately $252.